students, welcome back to another edition of DuckFlix. Today we are going to be covering lessons 7.5 and 7.6, multiplying fractions using comparison and modeling. Let's take a minute to review our lesson scale. By the end of this lesson, we want you to be able to compare and model by multiplying fractions. Remember, we want you to be at a level 3 by the end of the lesson. Let's review our standards for mathematical practices. We want you to be able to make sense of problems and persevere. That means push through in solving them. We want you to be able to reason abstractly and quantitatively. You need to think to yourself, what makes sense? We want you to construct viable arguments and reason with others, so make sure you're talking about math and explaining it. Using a model with mathematics to show your thinking, and have attention to precision. Make sure that you are checking your work. Let's review some rules to remember when multiplying fractions. When we multiply a fraction by a whole number, the product of the fraction and a whole number will be more than the original fraction that you started with, but it will be less than the whole number. When a fraction is multiplied by another fraction, the product of those two fractions will be less than the original fractions. Well, you're probably thinking, how can it be less than? It's because you have a part of a whole multiplied by another part or piece of a whole, so that is going to result in a smaller number. And then lastly, when we have a fraction that's multiplied by the whole number 1, the product is equal to the fraction. Because remember, when we multiply any number by 1, the answer, or the product, is always the other number or itself. All right, let's take a look at our I do. We're going to have 3 different scenarios using our 3 different rules. So our first one says, during the week, Caitlin is planning to eat 3/4 box of Lucky Charms cereal. So the first thing we're going to do is we're going to write an expression. And remember, an expression does not have an equal sign. If we have an equal sign, that's considered an equation. So we have, she's going to eat 3/4 box of Lucky Charms cereal. So we know that we have 1 whole box, so we want 3/4 or 3/4 of, remember when we say of, that means we're multiplying, 1 representing her 1 box of cereal. So now we want to know if the product will be greater than, less than, or equal to 1 box. Okay, we just went over a rule where 3/4 times 1, anytime we have our fraction times a whole number 1, the product is going to be the fraction. So I'm going to model it and we're going to solve, but using the rule, we already know that the product is going to be less than the 1 box of cereal. So now if we make a model, I'm going to draw a box of cereal. We're going to divide it into fourths. And we know that Caitlin is going to eat 3/4, or 3 out of 4 pieces, or 3 out of 4 parts, of this box. And so if we solve using the standard algorithm, we have 3/4 times 1. Remember, we can put 1 in the denominator because it doesn't change the value of that 1 whole. And 3 times 1 is equal to 3. 4 times 1 is equal to 4. So we get 3/4 as our product. And we are correct in that it is less than 1 box. Let's go on to our next I do. This one has Sophia and Gabby's family with 4 boxes. 4 boxes of Fruit Loops cereal. They ate 3/4 of the box of cereal during the week, or 3/4 of the 4 boxes, during the week. So we need to write an expression that will go along with our problem here. So we know we want 3/4, and we want of the 4 boxes. Of tells us to multiply, and we have 4 boxes. So our expression is 3/4 of 4, or 3/4 times 4. And we know that the product, we're going to see if it's going to be greater than, less than, or equal to 4 whole boxes. So let's go ahead and draw our model. We're going to make 4 boxes. And we're going to break apart these boxes into 4ths. If I was being more precise, they would be a little bit more even. And we're going to fill in that they have eaten 3 out of 4 parts of these 4 boxes of cereal. And then if we would like to solve using standard algorithm, then we would do 3/4 times 4. And we can place this over 1 if that helps you. If not, you can leave it and just know that you're going to multiply your whole number 4, that would be right here, by your numerator. And 3 times 4 equals 12. 4 times 1 equals 4. We're going to ask ourselves, how many times could 4 go into 12? 4 goes into 12 3 times. So we know that if we were to see how much of the boxes of cereal they ate during the week, we could say that they actually ate 3 boxes even. So now we can make our decision that the product is going to be less than the 4 total boxes that they have. Let's go on to our last I do. This time we have Alex, and he has only 1/2 of a box of Cookie Crisp cereal at the beginning of the week. He ate 3/4 of the 1/2 box by the middle of the week. So we would like to write an expression to be able to solve using a model and using standard algorithm. So our expression would be 3/4, because he ate 3/4 of, there's our multiplication, 1/2 of the original box that he had. And in order to do a model, we're going to have to use our area model. So we're going to break apart our model into 1/2, and we're going to shade 1 out of 2 parts to show 1/2 of the box that he started with. And then we're going to break up our model in 4ths. And we're going to see that there are 1, 2, 3 out of those 4 parts that were used up. So, out of the 8 total parts, because we have 8 boxes, 1, 2, 3, 4, 5, 6, 7, 8, we have these 3 that are overlapped. So we can say that the amount of Cookie Crisp that he ate was 3/8 of the box, of the original box, of that 1/2. And if we want to use the standard algorithm, we're going to multiply 3/4 times 1/2. We don't need to do anything with our denominators. We just multiply the numerators straight across, and then we multiply the denominator straight across. So 3 times 1 is equal to 3. 4 times 2 is equal to 8. Our number is already in simplest form because 3 is a prime number. That means it only has factors of 1 and itself. So we know that the product is going to be less than the 1/2 box. All right, now let's go on to the we do. Okay, now I've put this in a complete word problem. So we have Luca that has 3/5 of a container of cake batter ice cream left. Okay, that means he's already eaten some, to eat. If he eats 1/2 of the 3/5 container after school today, we want to know how much of the container will he eat today? How much of this container will be eaten today? So we want 1/2 of this 3/5 container. And I'm going to show you in model form, and we're also going to do standard algorithm. So the first thing we're going to do is pretend that we have a rectangular container of ice cream. I'm going to break this apart into fifths. And we know that Luca has 3/5 of this container of ice cream left to eat, and he wants to eat this after school today because cake batter ice cream is delicious. And now we're going to break apart that 3/5 into 1/2. And then we have 1 out of our 2 parts that overlap. And we have 3 out of our 10 boxes or 10 parts that overlap one another, these 3. So he is going to eat 3/10 of this container today. And as I said in the last problem, 3 right here is a prime number. So it has factors of only 1 in itself. So this here, 3/10, is in simplest form. So he will eat 3/10 of the container today. And if we want to do the standard algorithm, we simply multiply the numerators. 1 times 3 equals 3. 2 times 5 equals 10. And we get our 3/10 once again. Okay, now let's go ahead and pause the video. Go ahead and read this problem and make sure you pay attention to the note. I would like you to model your answer and also show me in standard algorithm. We'll come back in a second and check. And we're back. Okay, so for this problem, we have Miss Walker visiting a farm over the weekend. And we have 6/8 of the animals are living in a barn. Okay, they live in a barn. 3/5 of these barn animals, okay, so of these 6/8 animals, are donkeys. We want to know what fraction of the barn animals are donkeys. So what fraction? Barn animals, donkeys. So we would have set this up by saying 3/5 of 6/8. And if we wanted to do standard algorithm, you would do 3 times 6 is 18. 5 times 8 is equal to 40. And then we want to see what number or factor both 18 and 40 have in common. We know that we can use 2, so we're going to say 18 divided by 2 and 40 divided by 2 equals 9/20. And 9 and 20 don't share any common factors, so we know that we can't reduce this any further. So this number is in simplest form. So 9/20 of these barn animals are donkeys. Okay, take a minute to record and reflect on your learning today. Write your end of lesson scale in your notebook, and we will see you in class tomorrow. Have an awesome night.